Hi folks. So today we're going to be doing the chi-square lab, which is essentially inference for many proportions. We had a lab about a single proportion, and then a lab about a single mean, and then we had a lab about differences of proportions and difference of means. The last lab we had was about ANOVA, which is about inference for many means, and now we're doing chi-square, which is inference about lots of proportions. So as always, we're going to start by loading our packages, library tidyverse and library infer, and I'll hit the play button to run those. And then we're going to use that same example data set I've been using all semester, the GSS data. It's popped up in my environment. And when we do chi-square tests, there's two main tasks that we could do. One is we could perform a goodness of fit test, and that just works on one categorical variable. And the other one is we could do a test for association, and that's about two categorical variables. So I'm going to go through both of those. Both of these tests are using the chi-square distribution as our distributional approximation. We could also have done a randomization test, but we're going to use the chi-square distribution. So we need to check a condition. And in this case, the condition is that each of the expected counts needs to be at least 5. So we're going to start with the chi-square for goodness of fit test. So in this example, we're going to think about this variable general happiness in my data set. And I need to scroll over. I think it's pretty far over. There we go. General happiness. So this is things like pretty happy, very happy, or not too happy. So it has more than 2 categories. So I'm going to have more than 2 proportions to do a test about. And the null hypothesis that I'm going to test is that the proportion of people who are not too happy is equal to the proportion who are pretty happy, is equal to the proportion who are very happy, and I'll just write that as 1/3. So they're each a third, a third, a third. And the alternative hypothesis is at least one of the proportions is different. So we can start by looking at a summary of the data, and this is a little bit complicated. So I've written the pipeline for you already. GSS, then we're going to drop the rows that have NAs for general happiness. We're going to group by general happiness. Then we're going to summarize n is equal to the count, the number in each of the categories. And then we're going to mutate, make a new variable, the prop, which is n divided by the sum of n. So if we hit the play button, we get some output here and a little message. You can ignore the message, but we want to look at the n's here, and maybe we could also look at the proportions. So it looks to me visually like at least one of these proportions is different than 1/3. This one looks pretty close to 1/3, but the other two look pretty different. So my guess is that we're going to reject our null hypothesis. But really why we're looking at this table is to see if the conditions for inference are met, and we can assume so, because all of the observed counts are so much greater than 5. So if we were going to do this in a more rigorous way, we would need to find the observed counts 1/3 times the total sample size and see if that number is greater than 5. But because these are so big, I think we can just assume that all the expected counts are greater than 5. So now we can use the chi-square test function to do the test. This works a lot like other tests we've seen in this class. We take our data set and then we pipe into the chi-square underscore test. And then we just specify one variable when we're doing a goodness of fit test. So my response is going to be that general happiness variable. And if I hit the play button here, I'm going to get some output. So I haven't had to specify any null proportions because by default, the chi-square test function is going to test the null hypothesis that all the proportions are the same. And so let's just write down a few things. We've got our test statistic, which is 616. We've got our degrees of freedom, which are 2. And then we've got our p-value, which is 1.96 e minus 134. So it's 0.000 133 zeros and then a 1, so it is basically 0. And so then the question is, what is the conclusion to our test? Do we reject or do we fail to reject the null hypothesis? In this case, we reject the null hypothesis. So that's our generic conclusion. We have evidence to suggest at least one of the proportions is different. So that was a goodness of fit test. Now we're going to move on and do a chi-square test for association. So we're going to think about the relationship between marital status, and marital status has a few categories as well. Let's see if we can scroll over and find it. It has things like never married, separated, married, divorced, widowed. Is there a relationship between that variable and the general happiness variable? So the null hypothesis here is that there is no association between marital status and general happiness, and the alternative is there is an association. So these are pretty generic hypotheses. You would just substitute in your variables there. Again, we should really check to make sure that our conditions are met before we go on. So I'm gonna hit the play button here. And I get a lot more numbers here because I have a lot more categories, but let's see what the smallest number I see is. Looks like 15. And so again, we can assume the conditions are met because the smallest observed count is 15. So we're going to proceed with our test, and we're going to use that same chi-square underscore test function that we used before. Take our data set, pipe it into the function chi-square test, and now we're going to have a response variable, and we're going to have an explanatory variable. It actually doesn't matter which one you pick as your response and your explanatory. I'm going to use my response as marital status, and I'm going to say my explanatory is equal to general underscore happiness. And again, I don't have to specify anything because the default for this function is just going to test if there's an association. Hit the play button. Again, let's write down what our test statistic is. It's 202. The degrees of freedom are 8. And the p-value, again, it's essentially 0. 2 times 10 to the minus 39, it's 0.000. Lots of zeros, so it's essentially 0. Again, what is the conclusion of the test? We either reject or fail to reject. And in this case, we also reject the null hypothesis. We have evidence there is an association between marital status and general happiness.